Well, you know, before we get there, let's figure out what the other value is. Remember, this is VF, the final velocity of 5. So we have two x's here, so we have M and Q. Only two answers here. This was -2 meters per second. -2 or 2.5. If Q is -2, we'll just plug and chug. We got an equation right here for M. This is 2/3 minus 5/3 times -2, which is 2/3 plus 10/3, which is 12/3, which is 4. And if we plug in the other one, we plug in 2.5, I have 2/3 minus 5/3 times 5. Let's see if I can actually write that, something remotely related to our English or Roman numbers. What are our numbers called besides numbers?
Digits.
What's that?
I said digits.
Remotely as the numbers that we were all, I'm guessing we were all taught. 5/3 times 2.5, which is 2/5. So what you got?
I got -3.52. I see, that's you.
Oh, wait. That's 5/2. Sorry, I wrote that. The way I wrote it, the answer would have been 0. Oh, sorry, I mean, so what did we get?
Yeah, still -3.5.
-3.5. All right. So our two answers are that or this. This is true or this is true. Why is the first one not true? But it does bring comfort because I know we did something right because I was expecting that as one of our answers.
The blocks would have to like go through each other, or they would hit again, or something like that.
All right. So this has box, this 5 kilogram box starts out with a negative velocity. If it ends with a negative velocity, that means it keeps going this way. The other one goes that way. They're passing through each other. It actually also is the non-collision solution. That's what we started with. The advantage of this method is you're looking for a combination of velocities so that my momentum is the same and my kinetic energy is the same. Well, if they don't touch, and I got nothing else going on, my momentum is the same and my kinetic energy is the same. So this is the non-collision solution, or they pass through each other's solution. So that is not valid because I did say they collide. So this is the other solution, or that is the solution. But the big advantage of this method is that one of the answers should be what you started with. That way you have some confidence that you've done something correctly.
I was lost in your whole non-collision collision, but I get it now. What he's saying is, you see how up there the velocity is 4 meters per second, 2 meters per second. So one's going positive 4 meters per second, it's like -2 meters per second. So it can't be what we started with. Because that means they just go and keep going. So the -3.5 and 2.5 is if those two things were to collide. So they just can't have the same answer that we started with.
And they also end up bouncing off each other. Because after the collision, the 5 kilogram mass is going this way at 2.5 meters per second, and 3 kilogram mass is going that way at negative, at 3.5. Right. Questions on this?
asking a question like this on the test, do you want both the answers we get?
If I give you a perfectly elastic collision problem on the test, whichever tech, I'm looking for basically that. If you do it this technique, this will be coming up, you'll come up with this, but you need to recognize that that's the actual answer.
Okay.
All right, so let's solve that again, except without the numbers. You need some numbers when you have letters. So I'm going to use A as my beginning and B as my, so I'm going to set this equal to capital A and this equal to capital B. So I have mass 1 times A plus mass 2 times B equals mass 1 times M plus mass 2 times Q. This is just momentum of the first object plus momentum of the second object is before the collision is equal to the momentum of the first object plus the momentum of the second object after the collision. Energy, kinetic energy should be conserved, so I got 1/2 m1a squared plus 1/2 m2b squared equals 1/2 m1 big M squared plus 1/2 m2 big Q squared. So this is exactly what we just did. I'm just putting in the letters in instead of the numbers. I'm going to simplify the second equation. I'm just going to multiply everything by 2. So this becomes m1a squared plus m2b squared equals m1 big M squared plus m2 big Q squared. I'm now going to organize it so all my m1s are on one side and m2s on the other. So I'm bringing this over to the left, that over to the right. And in my first equation, I'm going to do the same thing. I'm going to bring this one over to the left, that over to the right. So from the first equation, I have m1 big A minus m1 big M is equal to m2q minus m2b. So just the first equation, just rearrange some stuff. The same thing with my quadratic here. I have m1a big A squared minus m1 big M squared is equal to m2 big Q squared minus m2 B squared. Let's do some factoring. I'm going to factor the masses out. So I have m1 A minus big M is equal to m2 Q minus B. I can do the same thing for the second equation. So I have m1 A squared minus big M squared equals m2 Q squared minus B squared. Dramatic pause for questions. All right, let's keep factoring that second equation. A squared minus M squared. What is that? How does that factor? Difference of perfect squares.
It's A minus M times A plus M.
Without the question mark, yes. So I have M1. A minus M equal times A plus M is equal to m2 q minus b q plus b. Now, the math people are telling me that if I divide both sides by the same thing, it's legitimate math. So I'm going to divide both sides by things that are equivalent. I'm going to divide the left-hand side by m1 a minus m and big M. And I'm going to divide the right-hand side by m2 q minus b. They are equal to each other. We got that from our momentum conservation equation. I can now cancel out common terms, or common factors. M2 cancels out, q minus b cancels out, m1 cancels out, a minus m cancels out. What I'm left with is a plus m is equal to q plus b. This is the initial and final velocities of mass 1, the initial and final velocities of mass 2. I guess final and initial. I'm going to change the order around slightly to go for a more traditional look. So I have a minus b is equal to q minus m. In other words, I have v1 initial minus v2 initial is equal to v1 final. Sorry, try that again. v2 final minus v1 final. This is known as the relative speed of approach is equal to the relative speed of recession. So, bless you. I have my 5 kilogram mass and my 3 kilogram mass heading towards each other in this reference frame, in our what we'll call the lab frame or the problem frame. They are going to collide. Now, if I look at this from B's point of view, so this is, we're standing on the side here, we're watching these two things come towards each other. But if we're looking at it from B's point of view, how fast is A coming at it?
6 meters per second.
Yes, it's the difference between the two, 4 minus negative 2. So in our problem over there, it's going 6 meters per second is the relative speed of approach. That should equal the relative speed of recession. So from B's point of view, A's coming at it at 6 meters per second. After the collision, from A's point of view, B should be going away at 6 meters per second. In other words, V2 final minus V1 final, which is 2.5 minus negative 3.5, which is which is 6. If we solved it this way, we avoid the quadratic. So I have 2 is equal to 3m plus 5q, and then I've got this equation here, which was 4 minus negative 2 is equal to q minus m. Six is equal to q minus m. Q is equal to 6 plus m. Plug that in here. 2 equals 3m plus 5, 6 plus m. 2 equals 3m plus 30 plus 5m. Negative 28 is equal to 8m. M equals negative 3.5, which is what we had before. This again, this would be the V3 line. And find Q, well, it's 6 plus that. Let people get caught up and ask questions.
So is the main formula for this just VI minus V2I equals V2F minus V1F?
Yep.
That's just
That's
main-
the second equation. First one's still concentration per liter.
So the rest, so like the ones that we did before, is just like a proofing of how we got to our final second formula?
You don't have to go through all of that
Okay.
derivation. If that's the method you choose to use. Jackie, would you have a question?
And the first letter in there's a VI initial? Well,
V1 initial, that's supposed to be an I. V1 initial minus V2 initial. All right, here we go. We did it the first time we had two solutions, one of which was the non-collusion solution, then we had the actual solution. What happened to that first solution, the non-collusion solution? At what point did it go away?
It went away when we solved for Q.
Okay, oh, no.
is it when we canceled out the M times A minus 1 and the M2 times Q minus B? Is that when it disappeared?
Not that point, but you're near it. Or, I guess you could look at it as, yes. But what is happening there to get rid of that solution?
We were taking out the original equation from so what we were actually working with was from the starting point, the M1A squared, and then what we were just trying to do is we were trying to remove the M1A plus M2B. So when we removed that, we essentially removed the non-collision equation from
Why
it.
does that remove the non-collision equation? What is A?
4 meters per second.
No, in general,
Oh.
in my derivation, what is A?
The initial velocity of mass 1, I think it was.
Yep. And what is big M?
Final velocity of mass one.
Yes. The non-collision solution is that doesn't change, that they're the same thing. So if they're the same thing, what is big A minus big M?
0.
Now, the math people do say that as long as we divide both sides by the same thing, we're good, except you can't divide by 0. In the non-collision solution, this is equal to 0, that's equal to 0. So, by assuming it's not 0, by dividing both sides by it, that's the point at which we get rid of it. All right. Two solutions for the exact same problem. Other questions?
So the math people don't like dividing by the M1 times A minus M.
They don't have a problem with this step mathematically, but they at least would acknowledge, assuming A does not equal M, assuming Q does not equal B. Just the blanket division, their issue is, if that's 0 or that's 0, then you got a problem. Because they haven't quite figured out how to divide by 0 yet. Next time you're in a math class, say, hey, why haven't the math people figured this out yet? It would make life a whole lot simpler. All right, let's take a look at it a third way.
Which way would you say is the easiest?
I like the third way personally, so when I'm doing it, I do it the third way. Based upon previous classes, it's a mixture of which, it's the way your mind is working at the time you have to use it. I've got mass 1, which is 3 kilograms, mass 2, which is 5 kilograms. I've got, so in the lab frame, this is going 4 meters per second. And that's -2, so P1, P2, this would be 12, -10. Questionable notation, but we're good enough. All right, so all I've done, this is basically a recap of what we did. For mass 1, the velocity in the lab frame, the way that I presented it is going 4 meters per second. This is going -2 meters per second. So therefore, the momentum of mass 1 was 12 Descartes, mass 2 is -10 Descartes, for a total of 2 Descartes. Just- We're gonna shift reference frames. So if I'm cruising along, let's say that I am walking along with mass 1. So the 3 kilogram mass, if I'm just standing here, is going at 4 meters per second this way. But if I'm also going 4 meters per second that way, how fast is mass 1 moving relative to me?
0.
So in the mass 1 frame, it's going 0 meters per second. How fast is mass 2 going?
6 meters per second. 6 meters per second.
Close. Looking for a velocity.
Well, I guess towards the negative.
Yeah, that's going -6. So whatever if I subtracted 4 from this one, I subtract 4 from that one. So this would have a